Welcome to EasyElimu channel. I'm Vincent Kanumai. I'll be taking you through Form 2 Mathematics, and today I'm going to take you through Pythagoras Theorem, Topic 8 of Form 2 work. We are going to consider a right-angled triangle and view out how we can find Pythagoras Theorem through that right-angled triangle. I shall draw one with sides A, B, C, and see how we can find identities and sides, and also find out Pythagoras theorem from that given triangle as below. Here I have triangle ABC, of which I have divided it into three sections, and then under that triangle ABC we are having side AB measuring C, BC measuring A, and CB measuring B. But we can divide or drop a perpendicular from C to meet line AB at D such that it divides that line and the distance from A to D be X. So meaning that the distance from D to B being C minus X. But remember, this triangle CDB is right angle together with the triangle ADC. Actually, because they are meeting at this point here at a perpendicular. And remember, triangle ABC is also a right angle triangle. So meaning that triangle BDC and triangle ADC and also triangle ABC are all similar, meaning they are resembling or having a resemblance in same. So I have already constructed some of them here. I've cut out the triangles, and I found the first triangle I cut is ADC with the measurement B and X alone. As you can see, the base here having measurement X and the hypotenuse of triangle ADC being B. And also I cut triangle DCB, and I found that the base of that triangle is C minus X and the hypotenuse is A. And also I cut the whole triangle, right angle triangle ABC, and with the base B, hypotenuse C, and height as A, as we can observe there. So from there we can say, since they are similar, it means that if I value out and find the scale factor, I will find it is same. So that if I take BC, if I take this BC of the larger triangle or the hypotenuse of triangle, let's take BC of triangle CBD, hypotenuse of triangle BDC or BCD, so that we have BC as the hypotenuse over the hypotenuse of the larger triangle here, which I have BA, should be equal to what I have as the base of triangle BCD, that is the base of triangle BCD, so that is BD, over the base of triangle ABC, and the base of that triangle is BC. According to that will be BC, such that we shall have here BC of this triangle here is A over BA of the larger triangle BA is C, such that I'm going to have BD of the triangle BCD here, which is similar to that of the larger one there, a triangle BAC or ABC. I will have here BD as C minus X. And also BC, you can view out from the triangle ABC, I'm having BC as A. So if I cross multiply, I'm going to get A squared is equal to, that is cross multiplication, such that A shall be multiplied by A and C by this. So I will have C into C minus X. That's what I have there. The same I can relate, because we said the three triangles are similar, I can still relate this smaller triangle, which is ADC, with the larger one here, and I still find that if I take the hypotenuse of the triangle ADC, that is the hypotenuse, meaning the hypotenuse AC over the hypotenuse of the larger triangle, which is AB, should be equal to the, now here will be my base, that is AD over, now if that is AD, I need to find the base of that one will give me AC. I'll take this AD from here to here and use that AD with the base of the larger triangle, which is AC, which is similar to that side of AD. So we shall find in that case. So on doing that, I'm going to have AC. For the smaller triangle here, I'm going to have AC as B, giving B, and AB of the larger triangle, AB, which I said the hypotenuse of the larger triangle, I'm going to have it as C. And this one should be equal to AD, which is the base of the smaller triangle, which is X, over, now the base of the larger triangle is B. And on evaluating that, I'm going to get, if I cross multiply, I will have B multiplied by B will rise to B squared, and C multiplied by X, I will get CX. So meaning B squared is equal to CX. That is what we find there. But remember, the first one gave us A squared equals to C into bracket C minus X. The other one has given us B squared equals to CX. So we need to find what is this Pythagoras theorem. We need to find Pythagoras theorem. So on doing that, we shall add the two values which we have found here. That is A squared. So we are going to take A squared, which is equals to C minus X, and then we shall add to the next, which is B squared equals to CX. And on adding this, we shall take those on one side, we add them, and the other on the right hand side, we add them together. For this case, we are going to take A squared, which is on the left hand side of the equal sign, we add to B squared, and we shall have A squared plus B squared. It is equal to, now we shall expand this bracket here, and we shall have C squared, and this one is going to give us minus CX. I'm expanding the bracket. So we shall add those on the right hand side, and I shall have, this is C squared minus CX, now plus this one will be plus CX. And on doing that, I'm going to have A squared plus B squared is equal to C squared minus CX plus CX will give you 0. So we shall remain with A squared plus B squared is equal to C squared. And with that, this is what we call Pythagoras theorem. And it always applies to a right angle triangle. And for that case, we shall be using this formula to find the sides or the missing side on the right angle triangle. For instance, we shall start with an example here, and we have been told that a rectangle measures 8 centimeters and 6 centimeters, and we have been told to calculate the diagonal of that rectangle. So what you shall do here, we are having a rectangle. This side measures 8 centimeters and this one is 6 centimeters. As I know, you have been required to find the diagonal of that rectangle, and if you evaluate that the diagonal, you will find that a rectangle has 90 degrees vertices joining each other. So meaning that the sides of that rectangle joins each other at 90 degrees. So you will have at each vertex is 90 degrees. So meaning the angles are always 90 degrees. If you construct a diagonal to pass through, it will give you a triangle which is right angled. For instance, like this. So we shall have a right angle triangle, and this side will be 8 centimeters, the same to this side. So you can calculate either of the diagonal, either this diagonal or the other one, which is the hypotenuse of the arising triangle, such that you are going to have a triangle of this perspective, whereby this one here is a right angle, and this is 6 centimeters, and this is 8 centimeters. So if you need to find this, remember what we said. In order to find here, this one will be referred to as a C, and this one will be as A, and this one B. So meaning that if we assign that way, as we had seen earlier, since A was like our height, B was our base, and C hypotenuse, such that we had A squared plus B squared equals to C squared. For this case, we shall now have A, which is 6 squared, plus B is 8, so it shall be 8 squared, will be equal to C squared. So if we need C squared, we shall take 6 squared is 36, plus 8 squared is 64. If you add it together, you are going to get 100 square centimeters. But we need C. So if you want to find the value of C, you are required to find the square root on both sides. And finding the square root on both sides, we are going to have C equal to square root of 100. You will have it as 10, and square root of square centimeter, you will have it as a single centimeter. So it will be 10 centimeter. So meaning this side will be 10 centimeter, and that side, or the hypotenuse of our triangle there, represent the diagonal of the given rectangle. So that is how you can evaluate out any given situation, and you can use the given formula, given knowledge, or given technique to evaluate any problem related to Pythagoras theorem without any difficulties. With that, I have come to the end of our topic today. I believe the topic has been interesting. See you in our next video.